Hi, my name is Kira Cole, and this is my teammate, Alicia Mitchell. Together, we're Team PiOS, or Pison iOS integration. So before talking about our project motivation, I'm first going to discuss the problem that it is we're trying to solve. So this is Pison's current workflow. The user makes a hand motion, which is detected by the sensors inside of the Pison device. It then identifies which motion was made and sends that information over a Bluetooth connection to a remote device. From there, it performs the desired task based off of the information that it received. However, their current system only works on the Android and Windows operating systems. So this is because each operating system has their own unique Bluetooth framework that is written in an OS-specific language. So then when they wrote this, to implement it for Android, they had to implement it in Java, but Apple's is written in Objective-C, so they actually can't access Apple's Bluetooth hardware. So this is the problem that we're trying to solve. So our project motivation is to gain macOS and iOS support, and to do so in a way that allows our library to be invoked directly from Java. There currently are no open source libraries that allow Java to access Apple's Bluetooth hardware. So the implications for our company would be full compatibility and sales. So they currently have no macOS or iOS support, but with this library, they could port all of their work from for Android into Mac. And so our best anticipated outcome is a fully functional macOS and iOS system, and that's invocable by Java as well. And so because it's never been done, one of the hardest challenges was just learning where to start. So the first thing that we did is we tried to interface Java with Objective-C directly, but hidden under the abstractions of these programming languages, they're actually very different. And so instead, we had to first convert from Java to C++, then interface C++ with Objective-C++, then interface Objective-C++ with Objective-C, have a Bluetooth manager written in Objective-C, get that information, and then send it back over to Java. And so the first thing that we did was the library that Alicia will be talking about, which is our Bluetooth Low Energy library, written in Objective-C and wrapped in Objective-C++. We then had to call into that library, and we were able to successfully call from Java into Apple's Bluetooth hardware. We were able to initialize the central manager, scan for devices, connect to them, and then populate services. This means that we were able to go through 4 different files written in 4 different languages with 4 different interfaces, and we were able to actually convert Java to Objective-C, confirm all of this through print statements because we couldn't use a debugger, and then we were able to communicate directly with Apple's Bluetooth Low Energy hardware through Java. So I'm going to turn it over to Alicia Mitchell to talk about our Bluetooth Low Energy library.
Okay, so one of the key issues that we encountered when working on the Java native interface was discovering characteristics. And so when we had this issue, every time we would call to discover characteristics from the JNI side, we encountered an issue where the central manager kept resetting itself. And because we couldn't access the stack directly for the central manager, we had to use a lot of print statements. And through extensive testing, we were able to determine that the reason the central manager kept resetting itself was because the pointer to the characteristics kept getting lost. So because the central manager couldn't access the characteristics, it couldn't invoke the Bluetooth hardware. And so even though we spent about a month on this, trying to fix it with the help of our TDs, but unfortunately we weren't able to find a solution for this. But another key accomplishment we had was the callback class, and the callback class is our Objective-C++ implementation, and it allows the conversion of the pure C++ objects to Objective-C, and so essentially it's a bridge from JNI to Objective-C. And so it passes all of the relevant information and objects from JNI to Objective-C, such as the central manager state. And the reason this was necessary is because the Java native interface needs to be written in pure C++, so any direct contact with Objective-C would cause it to break. So our Bluetooth manager class had a few functions, these core functions that gave it the Bluetooth access. So it was able to initialize a central manager, scan for a device, connect to a device, discover services and characteristics, as well as read from a characteristic, write to a characteristic, and notify if the characteristic value changes. And essentially, services and characteristics just deal with passing data to the peripheral. So this is an example of the central manager dependencies. So for example, if you wanted to scan for a device, you had to first initialize the central manager. And so this allows Bluetooth access. And if you wanted to discover characteristics, you had to first discover services. So while we were working on our Bluetooth Manager library, one of the main issues we encountered was connecting to a device. So originally back in December, we had a connect function that worked. But when we came back in January, Apple had an update that caused a bug in Bluetooth communication. So every time we tried to connect to a device, a pointer was lost to it. So the central manager could no longer invoke the Bluetooth access. So in order to remedy this, we had to rewrite our Bluetooth manager code. And we used an open source resource that works with Node. And we were able to use their Objective-C code and adapt it to work with our code. So once we got Connect working, we were able to fix the Bluetooth Manager class and compile it into a dynamic library to be loaded into JNI. So even though we weren't able to accomplish our best anticipated outcome, we did accomplish most of it. And so what's left is to finish the JNI. And so in the JNI, we need to still finish discover characteristics, read, write, and notify, and then just to port it over to iOS. So a lot of what we did was pretty new to us. We hadn't really encountered a lot of the things that we accomplished during the semester. So the one thing we did have was C++. We had a great understanding of that. So what we actually learned was Objective-C. And Objective-C is pretty hard to learn because it's very syntax heavy and it's very easy to get a memory leak. And also Objective-C++, it's a hybrid language. So when we had to learn that, we had to be careful about object propagation between the two languages. And we also had to learn about a dynamic library and how to create one so that we could load it into JNI. And our Java native interface, that was pretty hard for us because when we were learning about it, we had to learn how to invoke certain methods from the Java side, and we had to make sure that every type matched the type that we wanted to transfer. So it was a lot of conversion between the 4 different languages. And then just Apple's Bluetooth Low Energy Protocol was something else we had to learn because you have the dependencies. So you had to make sure that you followed the specific protocol exactly, or else it would cause an issue, which we encountered a lot of. So we would just like to give all of our technical directors a big thanks because we needed a lot of support and help throughout this semester. So thank you.